Bismillahirrahmanirrahim. Assalamu alaikum, dear ones. Hope so you all are well by the grace of Allah Almighty. Students, in our previous lecture, we have completed unit number 3, which was about factors and multiples. Now we are going to start our unit number 4, which is factorization, HCF, and LCM. So, what does it mean, HCF? The abbreviation of HCF is highest common factor, and LCM stands for least common multiple. In this unit, we will study about differentiate, prime and composite factorization, about the highest common factor HCF, to calculate HCF by prime factorization and division method, about the least common multiple LCM, to calculate LCM by factorization and division methods, about the relationship between HCF and LCM of two numbers, and also to solve real life problems related to HCF and LCM. Students, in previous chapter we have learned how to find the factors of a number. In this chapter we will learn different types of factors and two useful methods for finding the factors of a number. Now student, what does it mean by factorization? Factorization means writing a number as a product of several factors. As you can see, here is the definition given, that is, factorization is the process by which a whole number that is not a prime number is broken down into its factors. It means that if a whole number is broken down into its factors and that number should not be prime number, then this process is called factorization. Factorization is the reverse of multiplication. As we know that in multiplication process we multiply the factors to get number, but in factorization a whole number is broken down into its factors. That is what factorization is, the reverse of multiplication. Next, move towards the concept about prime and composite factorization. We are familiar from the word prime and composite, but in the form of numbers. We have learned prime numbers and composite numbers. As the prime numbers are the numbers whose factors are just one and itself, and composite numbers are those which contains more than two factors. But here is the concept about prime and composite factorization instead of numbers. So let's understand the concepts with examples. As you can see here, the number 1 is, since 3 multiplied by 5 is equal to 15. 3 and 5 are the factors of 15, and 15 is a multiple of 3 and 5. Can 5 and 3 be further divided? Students, can 5 and 3 be further divided? No. So 3 and 5 are the prime factors of 15, which means that if numbers cannot be further divided, it means that numbers are called prime factors. Let's understand another example for composite factors, that is, since 4 multiplied by 15 is equal to 60. So 4 and 15 are the factors of 60, and 60 is a multiple of 4 and 15, as we know. But you can see here the number 4 is equal to 2 multiplied by 2, and also the number 15 can be written as 3 multiplied by 5. They can be divided further into two factors. So 4 and 15 are composite factors of 60. Students, 4 and 15 can be divided into further factors, that is why 4 and 15 are composite factors. Also 60 is equal to, in the place of 4 we can write 2 multiplied by 2, and in place of 15 we can write 3 multiplied by 5. Here we can see that 2, 3 and 5 are prime factors of 60. These are the prime factors of 60, 2, 3 and 5. But the composite factors are 4 and 15 because these can be further divided and these cannot be further divided. That is why these are called prime factors. Students, all the factors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30 and 60. Out of these factors, 2, 3 and 5 are prime factors because these numbers cannot be further divided. And 4, 6, 10, 12, 15, 20, 30 and 60 are composite factors because these can be further divided. Students, understood the point number 3 and 4 by yourself? The concept about prime and composite factorization is not difficult, it is quite easy. Just remember that prime factors are those which cannot be further divided and composite factors are those which can be further divided. And now here is the definition of prime factorization at page number 46. The definition is the process of expressing a number as the product of its prime factors is known as prime factorization. Means that if we have any number, then the product of its prime factors will be called prime factorization. Let's see an example, that is 35. The number is 35, which is equal to 5 multiplied by 7. We can see here 5 multiplied by 7 are the prime factors of 35. Also 42 is equal to 2 multiplied by 3 multiplied by 7. Students, these are also prime factors of 42. Next one is 210, which is equal to 2 multiplied by 3 multiplied by 5 multiplied by 10. These are also prime factors of 210. Students, this process of expressing a number as the product of its prime factors is known as prime factorization. Now let's see an example to find the prime factors of 136. Start with the smallest prime number that divides the number. 136 is an even number, so divide by 2. By dividing 2, the answer is 68. Now 68 is an even number, again divide by 2, then the answer is 34. Now 34 is an even number, divide by 2 again, the answer is 17. Let's see, the 17 is a prime number, so now divided by 17 and the answer is equal to 1. Now as the answer is 1, so stop dividing when there is no remainder. Now students, look at this division, that is 2 6 are 12, and now taking 1 carry, the number would become 16. 2 8s are 16. Now 2 3s are 6 and 2 4s are 8. 2 1s are 2, taking carry, the number would become 14. 2 7s are 14. Now list the factors starting from the first row, that is 2 multiplied by 2 multiplied by 2 multiplied by 17. So 136 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 17. So we can see that the prime factors of 136 are 2, 2, 2 and 17. The composite factors of 136 are 4, 8, 34, 68 and 136. Students understood the example number 1 and both of these parts by yourself. Now student, let's see, here is a note, that is when a number is multiplied by itself, the result can be written as follow. 2 multiplied by 2 is equal to 2 raised to power 2. We will read it as 2 raised to power 2. As the number is multiplying itself, so the numbers are 2, that is why their powers are also 1 and 1. So 1 plus 1 is equal to 2. If the numbers are same, then the powers will be added, as the power of 2 is 1 and here the power of 2 is also 1. So 1 plus 1 is equal to 2. 2 is being multiplied by 2 times. 5 multiplied by 5 multiplied by 5. Here we can see that the power of 5 is 1, here is 1 and here is also 1. So 1 plus 1 plus 1 is equal to 3. We can also see that 5 raised to power 3 means 5 is being multiplied 3 times. The number written on the top is the number of times a number has been multiplied itself. Students, the power 3 shows that the number 5 is multiplied 3 times. So instead of writing 5 3 times, we will write just it as 5 raised to power 3. Now students, our next concept is about highest common factors, short form HCF. Let us understand this concept through an example, that is, consider the number 16 and 24. The factors of 16 are 1, 2, 4, 8 and 16. It means that this number 16 can be divisible by 1, 2, 4, 8 and 16. Also, the factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. So here we can see that the common factors of 16 and 24 are, let us see the common factors, 1, 2 and 4, 3 is not common, 8 and 16 also not common, and 12 and 24 also not common. So the common factors of 16 and 24 are 1, 2, 4 and 8. So now in order to find highest common factors, let us see in the common factor which one the number is highest. As we can see here, the number 8 is highest in common factors. So we can see that the highest common factor HCF of 16 and 24 is 8. The HCF is also called the greatest common factor GCF or greatest common divisor GCD. The term HCF and highest common factors are used most frequently instead of GCF and GCD. Students, in order to find highest common factors, first of all find the factors of the number and then common factors, and then see which number is greatest in the common factor, and then that number would be called highest common factor. Let's see an example number 2, and part number 1 is find the HCF of 27 and 36. The factors of 27 are 1, 3, 9, 27, and the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Students, we can see that the number 1 is common, number 3 is common, and number 9 is common. So the common factors of 27 and 36 are 1, 3, and 9. Now, in order to see highest common factor, see the greatest number in the common factors, that is 9. The HCF of 27 and 36 is 9. Now there are two methods to solve HCF. First one is by prime factorization method and second one is by long division method. Today we will study prime factorization method, and in our next lecture we will study about long division method. So the HCF of two or more numbers can also be found by prime factorization. Consider three numbers 12, 18 and 60. The prime factors of three numbers are 12, 18 and 60. 2 multiplied by 2 multiplied by 3. These are the prime factors of the number 12. 2 multiplied by 3 multiplied by 3. These are the prime factors of 18. And also 2 multiplied by 2 multiplied by 3 multiplied by 5. These are the prime factors of 60. So we can see here the prime factors of 12 are 2 and 3, and the prime factors of 18 are 2 and 3, and the prime factors of 60 are 2, 3 and 5. Now let's find common factors. The number 2 is common. Also the number 3 is common. The prime factors of common to all the three numbers are 2 and 3. Now the product of common factors 2 and 3 is 6. As 2 multiplied by 3 is equal to 6, which means that HCF of 12, 18 and 60 is 6. Students, by this method of prime factorization, we can find HCF. First of all, find the prime factors and then find common factor and then multiply the common factors to get HCF. Students, here is an important point to remember that if we find prime factors of the numbers, then after finding common factors, we multiply the numbers to get highest common factors. But if we write all the factors of the given number, then after finding common factors, we just see which one is greatest in the common factor, and then that number would be called HCF. Now let's see an example. Find the HCF of 54, 108 and 144 by prime factorization. And the solution is, first of all, let's find the prime factors of 54, that are 2, 3, 3 and 3. So 54 is equal to 2 multiplied by 3 multiplied by 3 multiplied by 3. So we can write it as 2 as it is, and 3 and the number 3 as 3 raised to power 3. It means 3 multiplying 3 times. Now prime factors of 108 are 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3, as we can see here. And here the number 2 can be written as 2 raised to power 2, and number 3 we can write it as 3 raised to power 3, as 3 is multiplying 3 times and 2 is multiplying 2 times. Now next one, the prime factors of 144, as we can see here, 2, 2, 2, 2, 3 and 3. And now the prime factors of 144 are the following. So we can write the number 2 as 2 raised to power 4 and number 3 as 3 raised to power 2. As the common factor is just 2 raised to power 1, 2 raised to power 1 is here common, and here is also common 2 raised to power 1. So the common factor is 2, and also other common factor is 3 raised to power 2 from 3 raised to power 3. Here is also 3 raised to power 2, and here is also 3 raised to power 2. As you can see here, these two numbers and these two numbers are common. So we will write just it as 3 raised to power 2 means 3 multiplied by 3, that is 9, and 9 multiplied by 2 is equal to 18. Students, let's see an important point, that is the HCF is the product of the lowest powers of the common prime factors. It means that if we write factors of any number, then the common factor will be the lowest power of that number. Friends, let's move towards the exercise 4a and solve some questions related to our today's concepts about prime factorization. Question number 1, that is, find the prime factors of the following. Part number 1 is 360. Students, we have to find the prime factors of 360. So let's find. Now let's find the prime factors of 360. As we can see here, 360 is an even number. So divide it to the digit 2. So we can see here 2 ones are 2 and then 1 is here. It would become 16. 2 8s are 16 and 0 as it is. Again dividing to 2 as it is an even number. So 2 9s are 18 and 0 as it is. Again divided to 2 as at unit place the digit mentioned is 0. It shows that 90 is an even number. So 2 4s are 8. Again 1 is here and 1 0 would become 10. Now we can see here the number 45 is not even, so it is odd. Multiply 3 ones are 3 and the number 1 from 4 is here. It would become 15. 3 fives are 15. Now 3 fives are 15 and 5 ones are 5. We can see here the prime factors of 360 are 2, 2, 2, 3, 3 and 5. So we can write it as 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 and multiplied by 5. These are the prime factors of 360. Students, part number 2 and 3 is in your homework. Let's move towards the part number 4, that is 27,830. We can see at unit place the digit mentioned is 0, which means that this is an even number. So first we will divide it to the number 2. So 2 ones are 2 and 2 threes are 6. As 2 threes are 6, the number is left 1 and 1 will make it as 18. So 2 nines are 18, 2 ones are 2 and again the number left 1 will make the 0 as 1 and 0 is equal to 10. So 2 fives are 10. Now we can see here at unit place the digit is 5, which means that this number would be divisible by 5. So let's divide it to the number 5. 5 twos are 10 and the number 3 is here. It would become 39. Now 5 sevens are 35 and the number 4 that was left will be here and it would become 41. So 5 eights are 40 and the number 1 is here. It will become 15. 5 threes are 15. Now students, we can see here the sum of alternate digits 2 and 8 is 10 and 7 and 3 is also 10, and by subtracting 10 minus 10 is equal to 0, which means that this number can be divisible by 11. So 11 twos are 22 and the remaining number 5 is here. Now 11 fives are 55 and the remaining number 3 is here. And now 11 threes are 33. 11 twos are 22 and the number 3 is here. 11 threes are 33. Now 23 ones are 23, as 23 is also a prime number. So we can see that prime factors of 27,830 are 2, 5, 11, 11 and 23, which can be written as 2 multiplied by 5 multiplied by 11 multiplied by 11 multiplied by 23. Students, by keeping in mind the previous rules, we can easily divide the number to find prime factors. Students, coprime means if the HCF of two numbers is 1, then the numbers are called coprimes. Let's solve part number 1, 6 and 8. In order to find either this pair is coprime or not, we will find first factors of 6 and 8 and then common factors, and then we will find HCF of 6 and 8. So students, if HCF of 6 and 8 is equal to 1, then this pair will be coprimes, or if not, then this pair will not be coprimes. Let's see the solution, that is factors of 6, as we know that 1, 2, 3 and 6. Factors of 8 is equal to 1, 2, 4 and 8. Let's see common factors of 6 and 8 are, we can see here 1 and 2. These are the common factors of 6 and 8. So now HCF of 6 and 8 is equal to 2, as 2 is the greatest common factor. That is why HCF is 2. Students, we can see here HCF is equal to 2. It is not equals to 1, which means that this pair of 6 and 8 are not coprimes. Students, part number 2 and 3 is in your homework. Let's move towards the part number 4, that is 9 and 16. And the solution is factors of 9 is equal to 1, 3 and 9, and the factors of 16 are 1, 2, 4, 8 and 16. Now see, common factors of 9 and 16 is equal to 1, as HCF of 9 and 16 is equal to 1, which shows that the pair of 9 and 16 are coprimes. Now students, move towards the part number 5, that is 30 and 37. So let's see, the factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30, and the factors of 37 are 1 and 37. We can see the common factor is just 1, which means the HCF of 30 and 37 is also equals to 1. As the HCF of this pair is equal to 1, which shows that the pairs of 30 and 37 are co-primes. Students, question number 1, part number 2 and 3, question number 2, part number 2 and 3 is in your homework. So do practice of question number 1 and 2 and also understood the concepts and examples. Okay students, stay home, stay safe. Allah Hafiz.